Welcome to solverfy.
We're asked to prove that Kruskal's algorithm produces minimum spanning trees. In other words, to prove that Kruskal's algorithm does what it says it does. So, let G be a connected, undirected, weighted graph. And let S be the tree produced by Kruskal's algorithm. And finally, let E1 through En-1 be its edges in the order chosen. And of course, edges that are at the same stage, we can order arbitrarily. We just want to make sure the edges from different stages are ordered so that edges from one stage are ordered before edges in another. And now let T be the minimum spanning tree that contains all the edges E1 through EK for the largest possible value of K. And so we have that K has to lie somewhere between 0 and n-1. And now we're going to derive a contradiction by assuming that K is less than n-1. And now let T prime equal our tree T, and add to it the edge EK plus 1. Now, since T is a tree, it follows that T prime needs to contain a simple circuit, C. Of course, with the newly added edge EK plus 1. So there exists another edge, E in C, that is not contained in S. And this is because S is a tree. So if E were contained in S, then we would have S would not be a tree anymore. So moreover, we have this edge E was available at the stage where EK plus 1 was chosen. And therefore it follows the weight of ek plus 1 has to be smaller than the weight of e prime. Or I'll just call it e instead of e prime. Or we know that it comes first in the lexicographic order if ek plus 1 and e have the same weight. And now let's define another tree, or a graph, t double prime, to be our graph t prime, which is t with the edge ek plus 1 added, and now subtract from this graph the edge e. Well, it follows that the weight of t double prime is going to be less than or equal to the weight of t. Because the weight of ek plus 1 is less than or equal to the weight of e. So it follows that t double prime contains the edges e1 through ek plus 1. And we also have that t double prime is a minimum spanning tree. But this is a contradiction, because we assumed that k was the largest possible value. And therefore it follows that k is equal to n minus 1, and this implies that the tree obtained from Kruskal's algorithm S is the same as t, and thus S is a minimum spanning tree.